Hello everybody and welcome back. I hope you got a pen and paper ready, or a pen and a virtual notepad ready, because we're going to take a look at question number 20 on the 2003 Fermat paper. So let's have a look here. If A, B, and C are positive consecutive terms of a geometric sequence, and one way to express that they're positive consecutive terms, the consecutive terms is what's important. One way to express that is to say C over B is the same as B over A. They have a common ratio. And that's how you make a geometric sequence, is that you just keep multiplying the previous term by the same number, the common ratio, to get the next term. So if they are consecutive, they all differ by the same ratio. It's often called R. So if they're positive consecutive terms of a geometric sequence, then the graph of y equals ax squared plus bx plus c is... And then we have some possibilities. So let's read these possibilities so we know what we're getting into, we know what to look for, and we might even get a sense of how to approach this question. So it's a curve that intersects the x-axis at two distinct points. Okay? So for that to be the answer, we would need to know that no matter what A, B, and C are, as long as they're positive and consecutive terms of a geometric sequence, then we can factor ax squared plus bx plus c into two different linear factors, giving us two different roots. Okay. So another possibility here is that it's entirely below the x-axis. Now I don't think that's possible, and why I would say that is because if you imagine a parabola, if your parabola, and we're just sketching one, if it's entirely below the x-axis, it's got to open downwards. If it opened upwards, eventually it would cross the x-axis. And to do that, that would mean A has to be negative. And that can't happen because we're told A is a positive one, just like B and C are positive. So B is already out. Entirely above the x-axis, I think that's possible. If it were entirely above the x-axis, then it would have no roots. We wouldn't be able to find any real roots. Because if you found a root, it would have to cross the x-axis or just hit the x-axis, sort of like whoop. So there's a way to test that. So I'm starting to think we should be thinking about roots, factoring, quadratic formula, maybe even the discriminant. Okay, what's the next one here? A straight line. If it were a straight line, I think A has to be 0, but I'll think about that a little bit more. And E, tangent to the x-axis. So that's what I was just talking about. That means it has only one root. Okay? So I'm definitely thinking that roots are going to come into this. So let's go to our notepad. B is out. I think D is out. A has to be positive, so it can't be 0. And the second you get A not being 0, you're going to get a parabola, not a line. Okay, so D is out. So now we're just looking at A, B, and C. A, as I've said, would mean two different roots. So it'd have to look a little something like this. B, or sorry, no, C. No real roots. And then it would look a little something like this. And finally, E, only one root. It technically has two real roots, but they're the same root. So then that would look like, boop, boop. There we go. Just touches. Okay, so there's actually a neat way to test whether or not something has two different roots, no real roots, or just one root. And if you remember the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. If there are no real roots, it's because this expression here, you're trying to square root a negative number. So if b squared minus 4ac is less than 0, then no real roots. And that would mean that we have an answer of C. If that thing is exactly 0, then we square root and we get 0. And then we have negative b plus or minus 0 all over 2a. You'll get 2 of the same root. They'll both be negative b over 2a. So that gives us one root, and that would be e. And then if it's positive, then we get some non-zero number here, and so you'll have negative b plus that amount and negative b minus that amount, each of them over 2a, and those will be different numerators, and that'll mean you'll get 2 different roots. So because b squared minus 4ac has this property to sort of tell us, how many roots, what do they look like, that sort of thing, it's called the discriminant. So if you didn't know that, b squared minus 4ac is called the discriminant. Sometimes that pops up. So, but all we need now to do now is take a look at our b squared, our 4ac, and perform this calculation. So, because we know that c over b is the same as b over a, and I'm going to call that r, it's the same ratio, we can actually solve for c and b in terms of a. Right? B is a times r. And now b times r is the same as c, but of course that's a times r, which is ar squared. So now if we plug them into the discriminant, b squared minus 4ac, well, the b squared, that's just ar squared, minus 4a, and now c is ar squared. So this becomes a squared r squared minus 4a. We've got two a's, so a squared r squared. And that's definitely minus 3 a squared r squared. Now this part here is positive, so this whole thing must be negative. So b squared minus 4ac must be less than 0, and that means no real roots. And that was, I think, c. Lies entirely above the x-axis. That means it never crosses, so no roots, so we're done. So that's an answer of C for question number 20. In the next video, we're going to take a look at question 21, the first of the 5 hard questions, and we'll see what we can make of them. I do encourage you guys to try those before watching those videos. I do say this every once in a while, but really the best way to do well on these contests in the future is to actually practice. One of my favorite math enrichment teachers told me, math is not a spectator sport. You can only learn so much from watching me, so much from reading the solutions that Waterloo provides. You have to actually try it so you can identify your strengths and your weaknesses. And then come and watch my videos. Then come and read the online solutions that Waterloo has provided of their own. You can find those in one of the links in the description too. And then you can identify brand new techniques or see, oh, this is something I should keep in mind because I keep screwing this part up and I should remember blah, blah, blah. Okay, so, but more than any place, the last 5 questions you should definitely try on your own. Okay, so I'm going to go away and I'll see you guys in the next video. And do try those questions. Of course, the very first link in the description will take you to a copy of this contest so you can try it on your own before watching. Okay, so bye for now, and thank you so much for watching.